Alrighty, today we're at 18.2b and we are doing the same thing we did the other day, except for we're in radians instead of degrees. So you have a little post-it on your last set of notes that you might just want to transfer to this set of notes, or if you want a second post-it, I can always make sure that that happens for you. But you're just going to write those down on the second post-it if that's what you're choosing today. So, reference angle, friendly reminder from yesterday, it's acute. That means it's less than 90 degrees. It's positive, you know what being positive means. And it connects with the x-axis, so we always make our triangle go up or down. That leg of the triangle is going up or down. So, graph the angle in standard form. Because this is in radians, we're going to practice this because students sometimes it just doesn't click for them all the time. So I'm going to do the first couple just like we did the other day when we were just learning how to graph these. So this in math, in the unit circle from here to here is pi. Okay, and then one trip around the circle is 0 or 2 pi. Remember, that's called coterminal because they have the same graph. But one you might have taken an extra trip, or 2 or 3 around the circle. So this is 1 pi. This is 7/6 pi. So that's really 1 1/6 of pi. So I like to make this whatever my denominator is. So 7/6 pi, that's 6 out of 6. So what we're going to do is we have 1 pi here, and then we take this whole other pi that gets us to 2 pi and we cut it into 6 equal pieces. Now, you're not going to have to do this over and over again because you're going to start getting the hang of where a 1/6 of pi is. But there's our 6 equal pieces right there, and we have 1/6 of it. So we're going to end up right there. So there's our angle. So then we're going to connect it to the x-axis. And this is actually 1/6 of pi, but you need to probably have memorized, and if not, we're going to write it down up here. Pi over 6 is a 30-degree angle. So our reference angle, and I totally don't mind, if you write this up here, our reference angle back here is just pi over 6, or 30 degrees. But if we give you the angle in radians, you need to write the answer in radians, okay? When we go to evaluate, if you want to think of pi over 6 as 30 degrees to help you label your special triangle, it's totally fine. But when you're asked a question about the reference angle, if it's given to you, the original angle is given to you in radians, then your reference angle needs to be reported in radians. Okay, 5/3 pi. So that's 2 2/3 of pi, right? Nope, that's wrong. That's 1 2/3 of pi. That's all right. Okay, 1 2/3 of pi. So here's 1 pi. So this is 3 out of 3. And then I have 2/3 of pi. So again, 2/3 of pi is like cutting the bottom half of this into 3 equal pieces. So I'm just going to white out that middle one. Just, you don't have to do that, but do you see those 3 equal pieces? And this tells me that I have 1 whole and then 2/3. So the tricky part is that we actually don't have like a whole in the unit circle is half, right? Because 1 is half instead of a whole, which is super weird, but it makes sense in terms of radians. Okay, so then I connect it with the x-axis. So if this is 1/3 and this line is 2/3 and the whole thing is 3/3, so I have 2 out of 3, so this little piece right there must be pi over 3. So for you guys, if you're noticing whatever the denominator is, if you just put a pi on top of it, that's your reference angle. You're almost always right if you're doing special triangles. If you're not doing special triangles, that's not a true statement, but if you're doing special triangles, that will always hold true. All right, 9 pi over 4. By the way, we might just add up here, pi over 3 is 60 degrees, and pi over 4, I should have put those in order, but I didn't, is 45 degrees, okay? So Again, pi and 180 are at the same point on the unit circle. So pi divided by 3, 180 divided by 3 is 60. 180 divided by 4 is 45. Alright, this one is going to be 2 and 1/4 of pi. So this is 4 pi out of 4. So I have 4. There's 1 pi, 2 pi, or 4 out of 4, 8 out of 8, and then 1 more. So here's 1/9 of pi. I'm going to drop it down to the x-axis, make my right triangle, and this right here is my reference angle, and it's going to be pi over 4. Easy peasy, lemon squeezy. 5 pi over 6 is going to be here. So I'm going to draw these lines one last time just so that you can see. So here's 1 pizza slice, 2 pizza slice. I know it looks like it's cut in half, 3. And so if I want to make 6, I have to cut all those thirds up into equal pieces. So here's 1, 2, 3, 4, 5, 6. So which one do I want? I want to get to here. So if you can kind of visualize these lines and make, you know, the size of the triangle and that inner angle small, then you can do that without having to draw them. So that's pi over 6. Okay? Moving on, we have negative 2 pi over 3. One important thing to point out right here is that reference angles are always positive, but this time we're going to be going in this direction, so it's going to be like that. How do I know it's there? Again, cut that into 3 equal pieces. There's piece 1, piece 2, piece 3, all the way back to here. But I only have 2/3, I don't have 3/3, so I only go to there. And then what's this going to be? Well, if this is 1, 2, and there's 1 left over, that's going to be pi over 3. That's going to get me to a total of 3 out of 3. If you want to write 1 pi over 3, totally fine. Like that. You can't put the 1 next to it because then it's a mixed number, and that's not what we're doing. Okay, negative 1 and 1/4 of pi. So I'm going to go negative 1 and 1/4. So I end up right here. Connect it to the x-axis, make my angle, and right in there is my reference angle. So that's going to be pi over 4. Right? So this is 4 pi out of 4, and it's actually negative because we came this way. So this 1 more would put me right there. Alright, now it's time for this post-it thing right here that we're going to be doing. It's the same thing. We can't use a calculator. The angles are given in radians, and we're using SOHCAHTOA. So the first thing we're going to do is draw the angle. So pi over 4, remember this is 4 pi out of 4 right there. So you're cutting that into 4 equal pieces, and when it's pi over 4, it's like saying 1 pi over 4. So you just go to the first mark, connect it with the x-axis, and then label your reference angle. So our reference angle is pi over 4, and pi over 4 equals 45 degrees. So that's going to help me label my special triangle. So I hear my computer making noise right now. It's kind of quiet. I hope it's not overpowering what I'm saying. I'm pretty loud at talking anyways. So we're just going to work through it because we need to get this video done. Alright, so the cosine of pi over 4, using SOHCAHTOA, cosine is adjacent over hypotenuse. So this is root 2 over 2 over 1, which is just root 2 over 2. Sweet. Okay, so very, very similar to yesterday. The only difference that we're dealing with right now is that our angles are in radians instead of in degrees. Okay, next one, cosine of pi over 3. So pi over 3 is going to be like here. So I'm cutting the top half, kind of ignoring the bottom half, into 3 equal pieces. So how do I know how many pieces? That's always your denominator. So there's piece 1, piece 2, piece 3 will get you back to here. But this is only 1 pi over 3. So I'm right there. This is going to connect to the x-axis. Because I'm in quadrant 1, this is pi over 3, which is 60 degrees, right? So that's going to be root 3 over 2. That's 1/2. That's 1. Cosine of pi over 3. Cosine is adjacent over hypotenuse. Root. Whoop, I was going to do a root. It's not. Adjacent is 1/2. So we're going to do 1/2 over 1, which equals 1/2. Sweet. Okay, moving on. Sine of pi over 3. So it's very similar to the one we just did. Here's our pi over 3 angle. We connect it to the x-axis. Because this is a pi over 3 reference angle, it's 60 degrees. So then when we label our sides, they're still the same sides. The only thing that's different is the SOHCAHTOA piece. So with that one, sine of pi over 3 is opposite over hypotenuse. So opposite our reference angle is root 3 over 2 over 1, which is simplified to just root 3 over 2. Okay, moving on. Tangent of pi over 4. Pi over 4 is going to bisect quadrant 1. Drop it down to the x-axis. So this is a pi over 4 reference angle, which is the same thing as 45 degrees. So this is going to be root 2 over 2, root 2 over 2, and 1. Tangent of pi over 4, which is opposite over adjacent, is going to be root 2 over 2, big fraction bar for that guy, over root 2 over 2. You can copy dot flip if you want, but we know any number divided by itself just equals 1, so why do that extra math if not necessary? Alright, so now what we're going to do is we're going to be getting out of quadrant 1, so we're going to have to really watch the sides of our triangle, whether or not they need to be positive or negative. So the denominator is 4, so that's 4 out of 4 pi, and I'm going to go to 3. So up here we drew a picture of pi over 4, so there was 1, there was 2, there was 3. So I'm bisecting quadrant 2 right there. I'm going to drop that down. Remember, reference angles are always positive, so that's still pi over 4, or 45 degrees. Hypotenuse is always 1. Positive y values because I went up, but negative x values because I went to the left. Okay? Cosine of 3 pi over 4 equals adjacent over hypotenuse. So adjacent to my reference angle, which is always with the x-axis, is negative root 2 over 2, and the hypotenuse is 1, so that's just negative root 2 over 2. Alright, 2 pi over 3. That's going to be like right here, dividing that top half into 3 equal pieces. So I'm doing it mentally, but then I end up drawing the line just to make sure you guys see it. But if you don't draw this line and you know 2 pi over 3 is there, that's great. If you make 2 pi over 3 over here somewhere, not great. It shouldn't be a small little angle. So this is pi over 3, which is 60 degrees. So this is going to be root 3 over 2, but this is going to be negative 1/2. Why is it going to be negative 1/2? Because it's in the negative side for x's. So this is the tangent of 2 pi over 3, which is going to be opposite over adjacent. We're going to have to do a little work here, so I'm going to try and cram this in. So root 3 over 2 over negative 1/2. And when I copy dot flip, I get root 3 over 2 times negative 2 over 1. It doesn't really matter where the negative goes as long as you only see it once. The 2's cancel out because we're multiplying, and I get negative root 3 over 1, which is just negative root 3. Okay? See, it should feel repetitive to yesterday. The just trickiest part is getting your angle drawn in the correct place. So I'm taking my post-it and putting it on the back side for the remainder of the 4 problems that we have on the back side for this type, and then we're going to do some calculator stuff, and then we'll be done. Alright, 11 pi over 3, 3, 6, 9, that's 9, oh wait, sorry, 3, 6, 9, so that is going to be 3 and 2/3. So this is 3 out of 3. That's just 3 out of 3. We need 11 out of 3. So you can either keep doing it that way, or you can go, this is 1 pi, this is 2 pi, this is 3 pi, and then I have 2/3 right there. So 2/3 is going to bring me all the way to here. And again, when you're doing this, you can see 1, 2, and then 3 right there. Okay, make the connection with your x-axis. This is a pi over 3 reference angle, which is 60 degrees. So this is negative root 3 over 2 because I'm down in the negatives. That's 1/2. This is 1. The sine of 11 pi over 3 is opposite over hypotenuse, which is going to be negative root 3 over 2 because it's opposite, all over 1. So that just gives us negative root 3 over 2. Ooh, 17 pi over 6. No big deal because it's out of 6. So this is pi and it's going to be 6 out of 6. So 6, 12. Or you can do it like this, 2 and 5/6 of pi. So I'm going to go 1 pi, 2 pi, and 5/6, which is going to give me a little tiny 30-degree angle over here. So my reference angle is going to be pi over 6, and that's 30 degrees. So then this is going to be positive 1/2. This is negative root 3 over 2. That's 1. Cosine of 17 pi over 6 is adjacent over hypotenuse. So then we get adjacent is negative root 3 over 2 over 1, which is negative root 3 over 2. Alright, now we got some negative angles. They're not going to fool us though. We have negative 4 pi over 3, so that's negative 1 and 1/3 of pi. So I go negative 1 and 1/3. So it's going to be right there. Have no fear, reference angles are always positive here. So even though that angle was pi over 3, the reference angle is still even though this was negative 4 pi over 3, the reference angle is still pi over 3, which is a 60-degree angle. And then I label my triangle, making sure to get the cosine as a negative because I'm on the negative x-axis. Cosine is negative 4 pi over 3, adjacent over hypotenuse. So that gives me adjacent negative 1/2 over hypotenuse of 1, so that's just negative 1/2. The sine is super important. Sine of negative 5 pi over 6, not quite to negative 6 pi out of 6, right? So it's going to be like right there. Make your reference angle, your reference triangle. This is theta. It's going to be pi over 6, which is 30 degrees. We're going to label this negative root 3 over 2. That side is negative 1/2. Hypotenuse is always 1. The sine of negative 5 pi over 6, opposite over hypotenuse. So we're going to get opposite is going to be negative 1/2 over the hypotenuse of 1, which is negative 1/2. Yeehaw. Alright. So the last thing we have to do today is work in the calculator, so it's going to go super fast. So here's this, here's the calculator. In the calculator, you're going to hit the mode button, and then you're going to make sure you're in radians, so you just hit enter. Alright, now I'm in radians, and then we have to type this in. So sine of 3, and you have to type in pi. Don't type in 3.14, you have to type in pi. Good thing there's a pi button right there. It's right below the clear button. Just make sure you hit second first. So there's the pi popping up into the calculator, divided by 10, close parentheses, and we are rounding to the thousandths. So there it is. Just a couple of button pushes. Alright, cosine of 3.1 pi equals, whoa, hit the wrong one. Cosine of 3.1 pi equals negative 0.951. You don't have to write the 0, it's just like a good habit to get into, so that's why I'm doing it. Look at this next one. It doesn't even have a pi, but that's okay. Tangent of 11.2. Unless there's a degree symbol somewhere, you're in radians. Most mathematicians work out of radians, So it's the default mode. Obviously, when you're first learning, degrees is easier, so you learn from degrees and then progress to radians, but because even though it doesn't have a pi, it's still going to be in radians. And I get negative 4.823. And last but not least, the sine of 7 pi divided by, not divided by, just the sine of 7.4 pi is what I meant to say. And we get negative 0.951. And that is it for today's lesson. Woohoo!